All right, Chapter 4, Section 1. We're going to learn about a little bit about graphing here. Yeah, this is going to be a graphing section. All right. I'm going to make this easy on you, but I'm going to make it where you got to do something too. All right. How many of you have seen Desmos calculator? Yes. Here's what it's going to help you do. It's going to show you if you made a mistake or not. All right? Do you use it on a test? No. But it's going to help you if you want to take a look and say, okay, am I accurate with what I'm doing? That's where you use it. It says graph each function. Graphing is nothing more than using the t. X and Y. What's my X value, then what's my Y value? If I put 0 in for X, and I'm looking at this one here, Y equals 3X squared, what's going to be my Y value, Preston? If I put 0 in for X, what's my Y? 3 times 0 is 0, okay? If I put 1 in for X, what's going to be my Y? 3. 1 squared is 1 times 3 is 3. If I put a negative 1 in for my X value, negative 1 squared is 1 times 3 is 3. We're starting to see a pattern here. I would still, just to help, I would put in 2 and negative 2. And the reason why I do that is because I want to see what this graph is really doing. It's starting to look like a parabola, right? If I put 2 into this, 2 squared is 4 times 3 is 12. Watch how my values start going up. And the same thing with negative 2, it's going to be 12. Look at how my values start to go. They start at 0, they go up 3, and then they really start jumping high at 12. So it's showing a parabola that's probably going to be looking something like this. It's going to get real thin real fast. It's not going to get wide. It's going to get thin. If I was to take Desmos and graph this to see what it looked like, get rid of this. Yeah, just clear it. Classes, go in here. If I was to take Desmos and I was going to graph that equation, see, am I accurate with what I'm coming up with? I would put y equals 3x squared. And if you take a look at this now, am I pretty accurate with this? Well, 0 at about, when x is 1, out about here. Actually, no, these aren't 1. This is actually 2, so it'd be in here. 2 is at about, yeah, because these are 4, 2, 4, 6, 8. Yeah, they ain't even right. All right. But you're going to see it's going to be narrow in a parabola. All right. If I was to take a look at, let's take a look at a fraction, like this one here, negative 5/6. What do you think that one's going to take a look at? Notice each one of these are x squareds. And if we look at an x squared on a graph, it's always a parabola, right? It's always a parabola. X squared is always parabola. So what do you think would happen? What if I made this 3x squared negative? What do you think would happen to that if I put negative out in front of this? It'd flip around, right? It goes from going up to going down. All right? So if we look back at this one here, where it's a negative 5, 6, what do you think that graph would look like? Which way would it be going? Yeah, it's a negative 5, 6. What do you think would happen? The graph would be going down, right? What happens when we put a fraction in here? What happens when we put a fraction? If we put a number into it and it gets narrower, when we put a fraction into it, it's going to get wider. It starts to widen out. Okay? This probably isn't a good fraction. I'm going to go back the other way and I'm going to just graph one here. Oop. Let's put 1 divided by 3 into that and see what happens. Let's grab another one. Let's put just y equals x squared. So you guys can start looking at what these start to do, right? And we'll put another one. We'll put 3 in there. Y equals x, not x, 3 times x squared. So you see what happens. As you get fractions, it gets wider. As you get, for coefficients, as you get whole numbers into it, it starts getting narrower. All right? So when we look back at graphing these, you get a kind of a feel for what your graph should start to look like. But just looking at the coefficients, this one's going to be a little wider. This is actually what? 2 2/3. So it's actually going to go wider on you. Narrower on you, I'm sorry. Graphing these, what happens when we, this is just, when we look at these here, stuff like this, we're just taking a parabola where the origin is the start of the parabola. It's starting from the origin, right? What happens down here when we start putting a constant on the end of that parabola, or on the end of that x squared? What do you think is going to happen? Well, if we do our t-chart, if x equals 0, y is going to equal 4. So what happens? We go up 4, and our parabola starts from there. All right? If this was a negative 4 here, our parabola would start down 4. Right? What happens here? We've got the square inside of parentheses. What do you think that parabola starts to do? Well, if I put 0 in for x, this would be 9, right? 0 in for x here, then this would end up being 9 if I use this one here. It'd be a negative 3 squared, which is 9. So now all of a sudden, it's 0 for x, it goes up to 9 up here. All right, would it start this way and do this? What if we put 3 in for it? What if we put 3 in for this? Then why would it be 0? Uh-oh. Yeah. Where does our parabola go? I'm going to tell you right now, it looks like this. It moves it across the x-axis 3. But notice we have a negative 3 in here, and it moved it to the right, the positive side. So it's understanding where your graphs are and what your graphs are doing. That's really what this section is going to be about. It talks about the vertex, the axis of symmetry, the min or maximum value, and the domain and the range of the function. Do that. We're going to jump into the assignment. in the assignment here is where you're going to start learning about each one of those. Axis of symmetry. If I was taking a look at, that'd be a good example. How many of you have seen the ball on a rope and you swing it around a pole and you hit it back and forth? Okay, you seen that? If I had a pole like this, and I had this ball or this rope and the ball, and this thing swung around this, right? I could say that this pole right here is my axis of symmetry. Okay, that right there is my axis of symmetry. That ball is swinging around that pole, and that's your axis of symmetry, is around the pole. So when you take a look at a parabola here, where would I be able to get even? Very good. All right. I look at this and I say, if this revolved around that y-axis, I would get the same shape, wouldn't I? So in this case here, my y-axis is my axis of symmetry. Okay? That would be my axis of symmetry. If I was going to graph something where, and I'd say this point right here is going to be 4, 0. And if I spun it around where this was 4, 0, then that would be my axis of symmetry. All right? That's what the axis of symmetry is. Vertex. A vertex is where your line changes directions. It actually changes slope. And if you look here, if I take a look at my slopes here, and as it gets closer to this 0 point, what's happening? My slopes are going from this direction back to this direction. So in this case here, my axis of symmetry, my vertex would be right here at 0. Because that's where it's coming down, and it's changing the slopes. Your slopes are changing, so that would be your vertex. Vertexes, if you were to graph something and it had this, each one, and you did on your last assessment, right? These are your vertexes where it changes direction. In that case, all it is the bottom one. Okay. Vertex form of a quadratic function. There is an equation right here, and you will have this in your assessment or your assignment for today. And it's this one right here. Y equals a times x minus h plus k. This is going to be able to help you find your vertex for a formula without having to draw it out. If I gave you 20 problems and I said go and tell me what the vertex is for each one of them, I'm going to guarantee you doing it this way is going to be much easier. On an assessment? No. All right. If you take a look at this equation, what are my variables in here? I got a y and an x. All right. I've got h and k. I want you to notice your h and k. What is H and K? It's the vertex of this graph. It's where it meets its lowest point. All right? So I look at my H and my K in here, and that's where it meets its, that's where it's changing directions. All right? So this, when you're finding that vertex, this is really what you're looking for. So if I was to take a function y equals x squared, or x plus 3 squared plus 2, what do you think my h and k would be in that case? Where would be my vertex? Remember this one, x minus h. X minus h shows where your h value is, or your x. H is -3. Okay? Right here. If I'm going to take my h value, it's really x minus h here, right? And we've got an x plus 3 here. We're going to change the sign on that one. So it's going to be a -3. So here's where our vertex is on that one. Where would be our line of symmetry? Wherever that x value is. Okay? What do I want you to do? Do 1 through 6. 1 through 6. And here's what they're going to want you. They're going to want to know what the vertex is and the axis of symmetry. That's it. They want you to graph them. Graph them. Just because somebody's been so talkative today, you can graph them.